Hello everyone, nice to meet you. Today I'm going to briefly explain about the simulation and each application class. Although the view here is written in Korean, but let me explain everything using English. Okay, so we have 15 weeks, and you can check if you go to the e-class, and then you can check the class name and then other relative materials. Especially if you go to the this menu, and then you can actually get the list of the classes basically. And although today I'm just providing the video, recorded video as a starter, but from the next week, yeah, we will have the face-to-face class. Okay, so you can actually come to the classroom and then listen to my lecture. So you don't have to worry too much about it. And anyway, so but if there is any the other online classes, although this is a face-to-face, but sometimes I provide material through the e-class here. So if you select this first menu, you can see the list of the lectures, and first two menus is more like the uh, real-time lecture, online lecture, and the others are and then you can also see the like a video link if we have any. Okay, here also we have a notice page, and if you go to the notice page from the second menu, and then usually I post the slide material here so that you can download the slide, and then attend the print out the slide, and then you can attend the class with the slide. Okay, here. All right, and then also you can check the assignments, and this is the assignment menu. And also there is the evaluation menu, but you can get the information, actually the your grade information at the end of semester particularly. All right, also as a lecturer, I can actually check the list of the lectures here. And the most important thing is that we have a syllabus for this class. And as you know, it's a title of this class is a simulation and each application. And some information is actually the mislead. So this is not the required course for the industrial and systems engineering. So it is changed. So basically, the all junior and senior student can take this class. Okay, but this is not as an optional class. So this is not required class for the graduation. Okay, so anyway, and then here's the information about the course, and we have 3 credit hour, and we are going to have a face-to-face class from the next week. All right, and then which means which means uh, March 7th, because the this week actually this class only have 5 students, but as an English but in order to continue this class, I need to have we need to have at least 6 students. Okay, one more student here, so that's why I mean everything is fine, and then definitely I can give the lecture. I can give the lecture actually next time. So you do as a first week. So first week is start from the today, basically the March 2nd, right? I'm sorry. So the March 2nd here, right? And then from what until from March 7th to March 8th. So basically this is the first week, okay? From Wednesday to next Tuesday. Got it? So after that, the total the registered number of students are once registered. I'm sorry. Once the registered number is fixed, finalized, and then that number is greater than 6, greater than 5, and definitely I will continue this lecture. So because I'm not sure really about how many students will register to this class, so that's why I'm giving you this online lecture, okay, for you, basically for us. And all the And the goal of this class is to actually introduce many simulation techniques, because particularly nowadays the digital twin, where the industry 4.0 becomes very significant in our society, also in future, right? So simulation will be the good class actually to lead that digital twin paradigm, also the industrial revolution, industry 4.0 in future. So you can learn about many systems basically with modeling, and you can learn about the modeling technique basically for the to analyze multiple systems such as manufacturing systems, logistics, where the service system, and so on. All right, and then if we have a chance, and then I will teach them multiple skills as well. Okay, so the basically we have five goals. One is so first, you can describe the fundamental logic, structure, component of, and the management of discrete event simulation. So this is a traditional way, and then but it's a very powerful way to analyze existing systems. So that's why. So once you have a good knowledge about the discrete simulation, basically you can learn about other simulation techniques. All right, and then you will construct a statistical distribution of the input data for simulation modeling. Also, you can develop a simulation model with basic and detailed operations. Also, you can explain simulation output with statistical method. Last, you can understand multi-simulation paradigms. All right. So basically, so that you at the end you will be the leader. Okay, of the what of the digital twin. Okay, environment basically. All right, so we have midterm and then final. Also, you will have many assignments, and then at the semester we have a project. So uh, definitely it will be the term project. It's a team project basically, and then also the team for the evaluation of the team project, and basically the I will you will have a chance to evaluate your peer. So peer evaluation methodology will be adopted, okay, to finalize the grade of the final project, basically. All right, and then we have multiple books, and then you can choose you basically the you can, if you have chance, and then you can use this textbook, but it's optional, okay? So I have a slide, so you can actually follow my lecture, and then you can uh, just download my slide and then follow the material. That's basically, okay, study the material. That's it. All right. What else? And then let's look at the course schedule, tentative course schedule in detail here. So introduction for the first week. And once again, because number of students is still five, so first week I will just give you the online lecture. But from the first week, we will have a face to face, so don't worry too much about it. And then here, fundamental simulation. What you will learn about the simulation concept next time actually, and then fundamental simulation concept as well. And then next, also, we will learn about the basic logic of the simulation, basically, including path analysis. I'm sorry, and queuing model, and basic operation methodology in Arena, and then also on other techniques as well, modeling technique in Arena, and input data analysis. So basically, we will use a tool. We will use a tool to develop the statistical distribution from the input data, basically here, and statistical analysis of output from the terminating simulation. So yeah, statistics is a kind of the necessary technique for this class, and we have a midterm exam in 8th week. Also after that, I will teach you how to use your Unity 3D to develop the VR or AR simulation. So if you, but it can be tentative because based on the progress, okay, from this 7th weeks and during the first 7th week, and then I will determine, okay, I will choose whether we need to learn about the VR simulation or not, okay. And after that, you will have at least 4 weeks to complete the term project, and then we have final exam. Got it? Okay. And once again, and then I will make an announcement, okay, here, so you can check the notice page actually to before you attend the class. All right, as a starter, I let me just briefly explain the one of my research, okay, which is about the agent-based simulation, so that you can understand how can we utilize the simulation technology for our study, or also the for your actually the career actually in future, right? So this actually this research has been done when I was a PhD student, okay, in Arizona, so at the University of Arizona, and then this the topic is entitled on agent-based simulation approach for dual toll pricing of hazardous material transportation. All right, so risk of the hazardous material transportation is very well known. So hazardous materials are any substance or material that could adversely affect the safety of the public, handler, or carrier during the transportation. For example, it's more like so carriers delivering what? Delivering gas, basically, okay, or other toxic chemicals, right? So if there is the accident of the hazmat, it's a hazmat known as hazmat, and then they basically we have to block the roadway, right? And then also the extinguish or and then the close the roadway entire or city, right? So that public, other people can avoid, okay, away from the that accident area, right? Because these are what get such as gas or chemical is what these are the what this is the uh, can cause harmful impact on the human's life. So that's why, okay. Anyway, unfortunately, there are multiple accidents in hazmat transportation, so that's why we want to. And then definitely they cause serious consequences in terms of death and major injuries. In 2020, in 12, in US there were 13,675 accidents caused by hazmat transportation. It's very huge, right? And about $59 million in damages, all right? And about 85.72% of the total hazmat accident occurred on highway with a total of 49 million in damages. And it continues, unfortunately. So mitigation of the risk caused by hazmat transportation is a significant issue. You got it? Yes. So there are two ways to mitigate this hazmat transportation risk. One is a network design policy. Another one is a dual toll pricing policy. Network design is very simple. We can restrict the hazmat traffic from the highly dense regular traffic flow, so that the regular traffic flow is separate from the hazmat, okay, traffic. So technically, it can very effectively, reduce the risk of the hazmat truck using this sign, right? Truck restriction area. But we have to waste, right, the usability of the certain road segment, right? Because all roadway should be, in order to increase the utility of the roadway, it should be used by what? All types of vehicles, right? So there is another policy called the dual toll pricing policy. So basically, we can impose different tolls, okay, on different type of vehicles, okay, so that the vehicle hazmat transportation can be separated from the regular traffic flow. Hopefully, okay, because people try to take the cheap roadway, right? So that's why. So this is more flexible, right? Because still hazmat truck can use the regular roadway, though that's why, and efficient, right? So that efficient, technically flexible and efficient approach for hazmat shipment than any policy. You got it? All right. So motivation and objective of this study is to design a realistic dual-toll pricing policy using agent-based simulation. And so ABS is known as ABS, and ABS allows us to consider the realistic road network environment in great detail. Why we are using simulation? Because you cannot test this kind of accident in real world, right? You cannot explode. You cannot make a crash, right, between the vehicle, because some drivers can die, right, because of your experiment, right? You cannot do that. So that's why we have to use a simulation under the virtual world, right? So that's why I'm using ABS. I use ABS, right, to test the impact of the different dual toll pricing policy, basically. So here is the structure of my simulation model. I have an individual driver decision-making process in my simulation. So in other words, it has AI while it drives, and it can change it can make several decisions, such as the right route choice, right, from the origin to destination. Another one, operation level, lane changing, car following, right? So it has AI, so that basically it can choose the route and then actually drive the car, right? Okay, so here's the structure of the my simulation-based optimization actually approach. Um, it has an optimization module as well as an agent-based simulation module. So this is a simulation module and then optimization module. Kind of hard, right? So optimization, if you have a knowledge about OR, operational research, and then you can understand this easily. So we have optimization module and then set the parameter. In other words, there is a decision-making variable, a decision variable. In other words, in this study is what? Is a dual toll setting, right? So under the given dual toll setting, we will conduct the experiment using simulation, right? And then there should be the simulation output, right? In terms of safety, right? And and if so, here we have three performance uh, criteria. So total, such as total public risk, total travel time, and total toll cost. So time, risk, cost, right? We have three criteria, and if uh, this is very satisfactory, and then we can stop the optimization, and then we can use the certain policy, right? However, it's not the optimum, and then we can change our policy multiple times, right, using this optimization module. And the next policy will be evaluated by this simulation model. And the third one also can be evaluated, fourth one, fifth one, right? So we have loop here. So optimization module will run the simulation multiple times, right, until it find the optimum solution, right? And this simulation is what? Is an agent-based simulation here, okay? So we have two-stage actually method here. Right, objective formulation. We see, because we want to identify the optimal dual toll policy, right? So here we have object function. This is a risk from the hazmat transportation, and then another travel. This is a risk travel time of the regular vehicle, and then this is travel time of the hazmat vehicle. So we want to minimize this actually the cost, right, from the optimization formula. And then there are criteria, right? So to control the traffic flow of the each roadway, okay? And also we have a duration population risk function as well to measure the risk of the hazmat transportation, right? And so we consider the travel time and population exposure along the link is the roadway, and then traffic flow at a certain link. So we have three uh, variables basically. And also, as I mentioned earlier, we have AI model, right, for the driver, right? So we adopt the extended belief design intention framework here, which is widely used to mimic human decision behavior, and basically is applied to the multiple cases here. So one is that there is an evacuation behavior modeling in Washington D.C. area under the terrorist bombing attack, okay, bomb attack. So here, and also the manufacturing system, this human behavior under the fire factory, and then also the error detection in a complex manufacturing system, and so on. So we have an AI model like this. So it has multiple modules. So under the given environment, like a roadway, right, and driver can perceive the information, right, through this belief module, and it has a own belief. So even though there is a 10-minute actual travel time, but some driver believe that that's a short And then some drivers can believe that, well, feel that it's really wrong, right? So each person, each agent can have different beliefs, and based on the beliefs, it can make a plan, right? So the route plan basically, uh, right? So we have multiple actual module here, but I'm not going to explain this really detail because it's too difficult for you. So that's why. And then basically we use several AI techniques like Bayesian belief network, and then extend distance field theory, probability depth for search algorithm, and so on. Anyway, to generate the route plan for each driver under the given roadway environment. So here BBN network. Let's look at this Bayesian belief network here. So Bayesian belief network include these 1, 2, 3, 4, 5, 6, 7 variables, and we have 5 environmental variables such as helmet traffic frequency, free flow traffic flow, distance from the destination, toll price. So considering that these 5, sorry, and each link driver can feel about the risk and then travel cost. It can be low, high risk, low travel cost, high travel cost. So based on that, you can generate the route plan. Okay, and so with using this extend distance field theory, I will skip this, and then also the, where is it? Probably the server search algorithm. So here, if you look at it, there's a loop here. So route plan is what? Is a combination of the multiple links, right? So basically, under the given information, we are using the probability to choose a certain roadway, basically. Calculate choice probability and then choose the route, basically, at the end. So I have an example, next page. And here we have an example, okay? So let's look at it. So this is the origin, and this is, let's say, this is a destination, okay? And then from here, initially the driver can have to select the one option, right? So as they, because there is only one path, right, from the node 1 to node 2, right? However, at node 2 there are 2 ways, right? Similarly, at node 3 there are 4 ways, right? 1, 2, 3, 4, right? So these are the choice probability from the load at the node 3, and then according to the choice probability, it can select the link, basically, likely select this link, right, with the 90% probability, right? So from node 3 to node 8, okay? However, still there's a chance to choose this link or this link, right? So that's the logic of the PDFS. Briefly, I just briefly explained it, because this is just the first class, right, to mention about the simulation. So it's a too new information for you, right? So I'm not going to give you too much information today. Anyway, I have AI model, right, for the simulation, for experiment, and then drivers. So that based on that, drivers can drive from this roadway environment, basically, in urban in New York, and it has 12 nodes and 18 links. So 1, 2, 3, 4, 5, 6, 7. Yeah, if you count the link, and then you can find the 18 links. And then we have 12 nodes. Okay, O, T, and then okay. And then data, we have a free flow traffic travel time, traffic flow, hazmat traffic frequency, and then exposed population and GIS information as well. I use the analogy. We are not going to use analogy in this class, but basically you can do the same thing actually in Arena as well. All right, and then we have different type of drivers, such as 500 risk taker behavior and the vehicles, and the 500 risk averse vehicle of the regular vehicle are considered, and then 100 hazmat vehicles. We have 100 hazmat vehicles, and here is the experiment environment and parameters. So basically the settings, okay, for the simulation experiment. And also, as I mentioned earlier, we measure the risk, travel time, right? And then also the cost as well, right? To identify the optimum policy. But in the experiment, I want to actually conduct some kind of sensitivity analysis. So here, for initially, we try to analyze the impact of the risk weight on the under the different dual torque price policy. So basically, the according to this experiment, we have two charts here. So first one showing the change of risk, and the next one showing the change of regular vehicle delay here. And then I change three different weight. I consider the three different weight here, okay. And then uh, risk weight. So W1 means risk weight, and here, as you can see, the Georgia price policy motivate what regular traffic flow to separate from the hazmat traffic flow, basically, okay. And then the risk decreases as what W1 increases. This is the increase, right? And the risk decreases, right? Because if we increase the W1 risk weight, and then is what the AI model should consider this one risk as a significant, right? So try to minimize the risk as much as possible, right? However, in this case, because we are considering this risk significantly, so in other words, what travel time, importance of the travel time can uh, can be disregarded, right? So that's why the travel time was increases, right? As what? As W1 increases. So it has opposite. The two figure has the opposite pattern. Mhm. And next one, impact of the weight on the regular vehicle travel time. So now we are considering the regular time more, okay, of the travel time of the regular vehicle, okay. So travel time is more important than the risk in this case, basically. So if we increase the importance of the travel time, and then definitely the travel time of the regular vehicle delay is kept reducing, right? And however, risk can be increases, right? Increase, right? So it has a still it has a opposite direction. And what about the hazmat driver's travel time? So if we consider the hazmat driver time very significantly like this, and the travel time of hazmat vehicle decreases as W3 increases, of course, because we are considering the hazmat driver's travel time significantly, right? And then, but in this case, if this travel time go faster, and then what? Regular vehicles will be very slower, right? So travel time was increased, right? So that's the difference, okay? You can see the impact basically of the three different weights, right, on the objective function, basically. So the dual price policy affected not only the regular vehicle traffic flow but also hazmat traffic flow. That's an important finding. So in other words, it implies that if we use a dual pricing appropriately, basically we can control the vehicle's movement, right? And I also did multiple research and additional study, especially to understand the impact of the drivers basically type, so driving patterns of the different driver types. So we have 200 risk takers and the 800 risk averse vehicles, who are not really care about the risk, all right, here. So impact of the dual pricing policy is very low in this situation, because why? We have more risk averse vehicles, mhm, than the risk taker vehicles. So in this case, uh, why? Because these eight, I'm sorry. So these risk averse vehicles are care really about the risk. So it is already took the really safe way. So hazmat traffic, regular traffic was already separated from the hazmat traffic. You can you understand that? Okay. So if you look at this figure, left side and right side, and then you can see the difference is not really great. I really big, okay? Really, the difference is not really bigger than those of the previous cases. like this. So So the hazmat, in this case, the hazmat transportation risk can be reduced by providing the potential risk information to the risk averse drivers because they really care about the risk anyway in advance before they drive. So that's why if we provide the risk information to them and they already took the safe way. Mhm. So here I can find several things. First, the proposed optimization approach using the agent ABS uh, can be used to find the optimal dual for pricing, dual toll price policy under the realistic road network. Anyway, the extend BDI framework was adopted to mimic the driver's route choice behavior. So it was a really first study to adapt the highly complex AI model here. And different behaviors based on the driver type can be modeled by the extended BDI framework. You saw that, right? So that's why several we can find that the several dual pricing policies are found with the various drivers' preferences and then decisions. And experiments show that what dual pricing policy motivate the regular traffic flow to separate from the hazmat traffic flow and efficient and effective when drivers care about the travel cost. Right? This is a finding of my previous study. And as a class lecture, and then basically if you use a simulation and then you don't have to do this risky experiment in real world, right? If think about it, if we do this experiment in real world, then what we have to uh, make accident, right? And then and or the we have to really make accident, or we have to carry the deliver the hazmat, right, from the origin and destination, and see how people really away try to avoid to or try to away from the hazmat carrier. And then if there is an accident like this, and then we have to uh, take a responsible for that, right? Maybe researcher some researcher has to go to jail, right? So in this case it's better to use a simulation. Okay, better to conduct a simulation study because it's a cheap, just safe, and also you can get the quite accurate result, right? That's why we need to learn about the simulation modeling as a great tool, especially in the future. Mhm. In future. And if you try to join the company, manufacturing company, and nowadays before they build the actual factory, they develop the simulation model to see the performance first, because they have to spend a billion or a million or $1 billion to build the building, right? So before they build the actual building, they want to conduct a simulation study. That's why it's better to learn about the simulation modeling technique, okay, in detail through this class. All right. Thank you for attending today's lecture. And because this is a first class, so I'm not going to spend the entire hour. And also, so if you have any question about this lecture, please email me. And then next time, hopefully I can give you the regular lecture. All right. So hopefully we can have one more student, okay, in this class. Thank you.